Hello everyone, in this video we are going to learn about fractional crystallization. And these are the two lesson goals that I would like you to be able to do by the end of this video. And whenever we talk about fractional crystallization, we always talk about Bowen's reaction series. So what is that series? It is a series of chemical reactions that take place in silicate magmas. And remember, whenever we have silicate magmas or silicate minerals, that means that we have a component of silicon plus oxygen. Okay? And this chemical reaction was first investigated by this person right here, Norman Bowen, and he was a Canadian geologist who did important experiments that help us a lot to understand the evolution of magma. Okay, and that is something that we're going to learn about in this video. So here is the summary of Bowen's reaction series. It actually consists of three different panels. On the left side here we have the temperature indicator. Here at the bottom we have high temperature, that kind of represents the temperature of the deeper part of the earth, and here on the surface of the earth we have a lower temperature. Okay, and on the in the middle section here we have the different types of minerals that solidifies at different temperature. Okay, and there are two main arms, and we're going to talk about that later: discontinuous series and continuous series. Okay, and here we have different types of minerals such as olivine, pyroxene, amphibole, biotite, orthoclase, muscovite, quartz, and here on the left arm for the continuous series, we only have one single mineral, which is plagioclase, that could have sodium-rich or calcium-rich composition. And here on the right side of the Bowen reaction series, this right panel, it actually represents the name of the rocks. Okay, so this is actually the name of the rocks based on its composition. Okay, we have ultramafic, mafic, intermediate, and all the way to felsic composition. Okay, now the nice thing about Bowen's reaction series, it actually can tell us a lot about what are the different minerals that will crystallize at different temperature. Okay, so for example, olivine will crystallize at that temperature, which is pretty hot. Okay, as well as the sodium rich plagioclase. However, if we found quartz, that means that quartz, these minerals, it actually solidifies at a low temperature, much lower temperature than olivine. Okay, and another nice thing about Bowen's reaction series is that it actually gives us a lot of ability to predict the mineral assemblage for different types of rocks, different types of igneous rocks. So for example, if I have a type of rock that I know that it consists of a little bit of olivine and mostly pyroxene and maybe a little bit of amphibole too, and a lot of plagioclase. Okay, so I know that these rocks, this based on this mineral assemblage, I know that these rocks would be mafic rocks, and I know that I can predict that these mafic rocks may form at these temperature right there. Okay. All right, so those are the importance of Bowen's reaction series, and the nice thing about Bowen's reaction series that helps us a lot about identifying different types of igneous rocks and different types of assemblages within the igneous rocks, mineral assemblages within different igneous rocks. Anyway, let's continue. All right, so well, all of these silicate minerals that I already mentioned, I don't know if you recall, but if you recall the last module that we learned about minerals, these are all the things that we discuss when we talk about the silica tetrahedron, right? We learned that there are many forms of silica tetrahedron. Here we have isolated tetrahedra for olivine, and then it goes to single chain tetrahedra for pyroxene, and then we have double chain tetrahedra for amphibole, and eventually we got sheet-like tetrahedra for biotite and muscovite actually, as well as the last one we got the three-dimensional framework of tetrahedra that represents quartz, orthoclase, as well as plagioclase. Okay. So these are all the silicate minerals, and these are, this is something that I emphasize on submodule, in the previous submodule when we talk about minerals. So as I mentioned earlier, that there are two types of crystallization of silicate minerals. The first one, represented by this left arm of this, within this Bowen's reaction series, is the continuous series of plagioclase feldspar. Plagioclase feldspar can have sodium-rich plagioclase or calcium-rich, depending on the temperature when it forms. And the second arm on the right here, we have discontinuous crystallization processes. Okay, and the example of the minerals that belong to discontinuous series is, are all of these minerals that I have right here. Okay, all of them, all the way to quartz. Now let's take a look at the two processes involved in both continuous and discontinuous crystallization processes. For continuous crystallization, the minerals begins to crystallize of a given composition. So, for example, here I have a complete liquid molten rocks. Okay, so I have molten rocks here, and the composition of this liquid composed of 50% calcium and 50% sodium, and at 1450 degrees Celsius, there's no minerals that are forming in these melt. Okay. However, if we keep dropping the temperature to 1440 degrees Celsius, okay, then this is the temperature when we start to get some minerals of plagioclase to form. Okay, and the composition looks something like that, because we have calcium that have already solidified, and sodium, part of the sodium that also has been solidified. So then it changes the chemistry of the liquid here. Okay, from calcium 50% to sodium 50% to calcium 30% and sodium 70%. And if I keep dropping the temperature to 1350 degrees Celsius now I have a totally, again, different composition of calcium and sodium, and again it also changes the composition of the liquid. And eventually at 1280 degrees Celsius, I will have no more liquid, because all those liquid have been solidified and become minerals, and the minerals now have that composition: calcium 50% to sodium 50%, which is the same composition as the original composition, right? Liquid composition. Okay, so what happened here is that the inside of the minerals will have a lot of calcium, but the outer part of that mineral will have a lot of sodium. Okay, but they all create one single mineral, which is called plagioclase. All right, so there you go. So that's continuous crystallization process, and there are actually several types of plagioclase feldspar. It goes from anortite to albite, and do I want you to remember this? Not really, but this is good to know. But if you're interested in becoming minor and major in geology, then yes, certainly we would expect you to know about these minerals and their composition. The next crystallization process is called discontinuous crystallization, which is the right arm of the Bowen's reaction series that we already saw earlier. So this happens when melt reaches the crystallization temperature of a mineral, and then the mineral forms and undergoes no further changes with subsequent cooling. So, for example, here I have a temperature of magma at 1900 degrees Celsius, and this is the main composition, magnesium silicate. Okay. Now, what happened here? I'm going to drop the temperature like what I did earlier, and at 1800 degrees Celsius, I will start to have one mineral forming, which is called olivine. Okay, and that is the composition of olivine right there. And then after that, if I keep dropping the temperature, then what's gonna happen here is just there will be just a lot more olivine that form at 1700 degrees Celsius. Okay, so it doesn't change the name of the minerals. The name of the minerals is pretty much the same. It's olivine. Okay, and then eventually at 1555 degrees Celsius, okay, this is the boundary temperature, and at about 1554, olivine will not form anymore. The type of the minerals that will form at 1554 degrees Celsius is actually pyroxene. Okay, so pyroxene that will start to solidify at a lower temperature than these temperatures. Okay, so that is what we call as discontinuous crystallization. First we have olivine, and then at any given temperature, in this case at 1554 degrees Celsius, it will simply change the mineral types, okay, from olivine to pyroxene. All right, so again, why is Bowen's reaction series important? First of all, it actually tells us the condition, the temperature and pressure that form the igneous rocks. Remember, these are the igneous rock types, and we're going to learn about the classification of igneous rocks later on in the next section. And then it also suggests the possible original melt chemistry that crystallized the rock. Okay, that means that by understanding this mineral assemblage, we can actually understand what is the composition of the melt that these particular rocks form. Okay, and the third one, it also allows us to predict the mineral assemblage of certain magma composition. And the last one, it is very important because we use this in classifying igneous rocks. So those are the things that I would like to talk about when for fractional crystallization. And again, there are actually a couple of questions that I would like you to answer. The first one, according to Bowen's reaction series, what is the correct order that minerals will crystallize from a cooling magma? And the next question is, which mineral is involved in the continuous reaction series? All right, everybody. So I think that is all that I would like to talk about in this video. And as usual, if you do have questions, let me know. And I will see you again in the next one. Bye bye.